I'm pleased to have the opportunity to come talk to you today about thinking about who's at risk and how one can use new tools to do rapid mapping of population exposure or potential population exposure. I don't have to remind you that last year was a pretty intense year on a number of fronts. We had this unusual hurricane season, but also fires and earthquakes and all sorts of other disasters. Of course, the interesting thing about hurricanes, I don't have to tell you, is there's a extended period of time when you're sort of wondering which way is the hurricane going to go. And at various points in time, the entire Atlantic coast population was potentially at risk of being hit. But of course, in actuality, only a small proportion of those people actually experienced the landfall or associated wind and flooding damage. So as most of you know, I'm sure, working in the field have an inherent understanding of who and where the population centers are. But of course, it's always good to see it on the map and to be able to explain where population centers are and who's vulnerable to external audience or to local and regional decision makers. So having data, first off, on just population distribution is useful from that perspective. And this kind of data can be used, of course, both by managers and by the press and members of the public. But one also might be interested in more details, not just where population lives, but where are the elderly, what's the housing stock that they live in that might be more vulnerable to a storm or certain kinds of damage, where are the urban areas in the coastal zone that's low in elevation. A lot of different data may be relevant to identifying specific populations. And of course, infrastructure is really critical. Transportation infrastructure, things that certainly have secondary impacts if they're affected by a severe storm, dams, power plants. Even in the case of Puerto Rico, there was a decommissioned nuclear power plant there. Cultural sites, of course, hospitals and other emergency facilities. These are important infrastructure. And of course, within the US government, there are groups, the Highfield Group and others that collect data on infrastructure, geospatial data, and make it available. Of course, I bet many of you, if you were involved, probably also use Google Maps or other tools, Site View, to get a sense of what's actually there. So getting access to this data and putting it together is an important way of understanding the context of any disaster that's imminent or after it's occurred. But more than looking at pretty maps, you'd also like to be able to get a quick estimate of, first off, how many people is that? So if you have a National Weather Service warning area, this is about a week ago in Michigan, it's a little polygon that appears from the Weather Service when there's a river outlook flooding. Wouldn't you just like to be able to go to the map and see, well, how many people actually live in that and watch it as it moves across the landscape and get that total? Or if you see an event like the fires in Southern California, wouldn't you like to be able to kind of get a sense, well, is that a really heavily populated area where those fires are occurring or not? Where is the plume that's aerosol optical depth from a NASA MODIS satellite showing overlaid with the extent of fires detected by satellite and then the population. So being able to put these different kinds of data together to get a sense of what the risk is, where is the potential associated effects of disaster is helpful. There was just an earthquake off the coast of Alaska, and of course it was concerned about a tsunami. One question, how many people are within a certain distance of the epicenter, but in the case of a tsunami, you might want to refine that query to kind of understand how many people live along the coast that could conceivably be hit by a wave. So, the ability to go from a simple query like a circle to a more complex spatial query like a polygon that you just draw in a client allows you to make a somewhat more focused or get a somewhat more focused answer. Now, these are not as accurate as if you had to, as if you used a geospatial information system, went and downloaded it and made the query in the tool, but remember, only GIS experts can do that. They can, it takes some time. They can't do it fairly instantaneously through a simple interface. This tool that I'm talking about, which is developed by our center, is an interactive map. It also accesses data from a range of sources. One of the ones here is called EONet. It comes from the NASA Earth Data website and allows you to look at historical hazard events. For example, you can see tracks of prior severe storms and hurricanes or fires, and allow you to do a little bit of retroactive analysis. And the way in which you can think about these tools, would be, we were actually interested in feedback. Here's a case where there was a weather service warning in an area along the I-10 corridor between two major cities. So you're not just worried about the direct impact of the hazard on a point, but how important is that point, for example, in disrupting a major transportation corridor? Or, of course, we're sitting here in the DC area, how many people actually live inside the Beltway, and what would happen if an event occurred here. As you think about these data, what one wants to start looking at is the way in which hazard occurrence may interact or have the way in which they may not be totally independent of where people live. And so one obvious question after many of the recent hurricanes is, for example, are the elderly particularly concentrated in areas of flooding? Some of my colleagues took a look at this using the type of data I've been showing and didn't find a correlation in the Houston area between where the elderly live and the flooding. But it's an important question to ask, and certainly one that's relevant in disaster response. And of course, as we move not only from looking at potential exposure to actual impacts, there are opportunities to bring in new types of data. This, I'm sure you've seen after Puerto Rico, was data from a relatively new satellite and an instrument called VEERS, which looks at nighttime lights and can detect the changes essentially in the electrical grid before and after Hurricane Maria. And we've been working with Miguel Ramon at NASA Goddard to try to improve this as an indicator and then incorporate this into kind of a near real-time service to make it available as a useful tool for measuring impact. You can actually already see this data in NASA's Worldview client, in which you see our original population data fading into the nighttime lights data, so you can get a sense of where there are lights, where there are people or not. It's nice for a center like ours to build a client. Not everybody will come to your site and try to use a client. What's more important is how do you get the data out and into tools that the community already uses. So for example, we've been working with a tool called GeoCollaborate, operated by the All Hazards Consortium, which is an industry consortium that helps in utilities coordinate fleet movements after a disaster. So after all the hurricanes, actually, I guess there were two phases of intervention in Puerto Rico where utility trucks were shipped to Puerto Rico in January. And those trucks have to go between states. They have to deal with issues related to way stations and finding housing for the crews and dealing with blocked roads. So the All Hazards Consortium has developed this tool called GeoCollaborate, which helps pull that information together in a collaborative way. What we did this past fall is add this little button here on the bottom left, which is an icon with people. And the point is it accesses the data service that I showed you previously in order to do something like draw a polygon around part of Puerto Rico and return the estimated population. So it's just a simple way of making the same type of query through a tool that industry and others use and get access to just a very basic piece of information about population exposure. Of course, not everybody using this is sitting at a desk with a web browser. How do you give this kind of capability to people out in the field who might be using mobile apps? And also think about how to take advantage of the location services that you get when you're in a mobile platform. So you might be at a point where you want to know the distance away from a facility or from an event. And of course, if you go to Google Maps, you'll just get the road distance, not the line of sight distance. So this is a very simple query that just allows you to say, well, how far am I away from say a nuclear power plant, or as with the case of the earthquake, what are the, how many people are living within a particular distance of the epicenter of an earthquake or some other event. And you may also want to quickly pull up information about those facilities. So it happens we have access to a nuclear power plant database that pulls information in from the International Atomic Energy Agency, and that gives you sort of detailed imagery of the particular site. There's actually operating information about it. And then you can do that little query about how many people live within a particular radius. That's where I live, where it matters whether my kid's school was within 10 kilometers or 10 miles or out, and I had one kid in and one kid out, which meant they got evacuated to totally different places. But that's important information to know if you're in the field. And just to start wrapping up, there are a bunch of other kinds of data that may be relevant, which some of the scientific community is producing. And part of our interest is trying to figure out what information is really relevant to the user, to the emergency management community, and what could be folded in. So, for example, we recently released a data set also developed at NASA Goddard, which is about the percent impervious surface in any particular area based on 30-meter resolution Landsat data. And one of the questions is what is that? How can that be useful for people who are thinking about flood response and how much asphalt in an area might affect flood levels, for example. Or does it have to be plugged into a hydrologic model that quickly uses that information to estimate what the flood levels might be? And so in that vein, we're recently also developed a global data set which has estimates of not just the total population, but specific age groups and the sex of area, males versus females, because those are important in thinking, of course, about vulnerability, if there are excessive number of elderly or children or women of childbearing age. Those can be important in thinking about vulnerability to disaster. In the US Census, of course, there are many useful variables, thinking both about individuals and households and other kinds of differences that may be important in, certainly in planning. One of the things we're doing with the New York State is mapping literally every building in the state, trying to detect using imagery whether the roof is peaked or flat, but useful in integrating into a decision support tool that may be interested in potential flooding impacts or wind or other kinds of damage. And of course, we have an Android version of the mobile app that I mentioned under development. So just to summarize, you can find these mapping tools on our NASA CDAC website. They're free, open to the public. You can also go directly to them or use that QR code to go directly to the iTunes store and download it. And you can also see the Fleet Response Working Group's GeoCollaborate tool. They keep a record of many of the recent events and some of the data that were delivered and how these were used by industry. And of course, you can go to the NASA site to find a whole range of data from the data systems that take data and deliver it to users from satellites. We're certainly interested in feedback on how to make these tools and services more relevant to emergency managers, and hope to be able to improve them and work with the community to make them more effective. Thank you.